further than that. So in sum, what was happening is the operating system vendors were saying, we need to have separation. We need to protect our most critical applications and most critical parts of the system from things that are less critical. Now, why do we have a problem with Trojan horses today? Because the IBM PC and its clones and the Apple both run or are only starting to get away from single-state hardware. That says any Trojan horse can do anything on the machine. There is no protected space. So any Trojan horse that you pick up from anywhere is not separable. In 2007, we're only starting to get back to the notion of two states of execution. So we had a good idea in 1970, which 37 years later, we're only now coming back to. Okay. Controlled separation, excuse me, controlled separation is a very important quality in computing. Read the references, Neumann's paper on PSOS and Karger's paper on the VAX VMM. Very good papers explaining what you want to do with separation and why separation is a good security primitive. Final fallacy. It's easy, we can do security ourselves. I can't tell you how many customers call me in late in the game saying, well, we've tried some security approaches and here's what we've done and here's what we've done. We've done this and we've done that, and it just isn't working. And the reason it isn't working is they've committed all of the flaws from the first 5 fallacies that I've presented, doing it themselves. Okay. We all know that program complexity does inhibit security. The more complex it gets, the harder it is to secure it. Quote from Turing was, this would be the 1950s, by the time machines are able to do such things, we shan't know how they do it. And I think we've gotten to that state very clearly with most of our modern computing devices. We don't know what they do. Applications, utilities, infrastructure, and operating systems are all mixed together in the same memory space. Web data delivery, excuse me, web data delivery, display, and fetch are mixed so that the web is able to broadcast to you a piece of code that you should run on its behalf. Sony and its rootkit is another example of you don't know what's going on. You put in a CD, you think you're just playing a CD on your computer, and yet it installs a piece of software. And we're getting the IP stack in all sorts of things, telephones and thermostats and refrigerators. Too much computing in my mind. But read the references. Okay, so what do I say are the smart ideas in computer security? First is we can help. You know, we security professionals, those of you in this room who are going to go out and do something in security in your professional careers, keep in mind some of the comments that I've made today. Keep in mind that security isn't easy, that privacy isn't easy, that you don't add them in at the last minute, that you have to be very diligent in how you do it. Beware the widget du jour. Beware the silver bullet, the solution that's going to fix everything, because it's not going to fix everything. It's going to complicate matters. And finally, recognize that even well-known failings still fail. You know, look at the examples that I cited from the 1970s, things that were known to be harmful in the 1970s. They're still harmful today. Single-state architecture, we got away from that in the early 1970s, and then we got back to it in the 1980s when the PC first appeared on the market, and we're only now getting away from it again. Okay. So we need to recognize what has failed in the past and be able to take steps that will protect us in the future. Okay, so my summary idea is you as computer professionals or as people who will become computer professionals are going to go out in the world and you're going to interact with non-computer people. And certainly non-software people and certainly non-computer policy people. When you do, keep in mind some of these messages. Realize that those people out there think security is easy. little security fairy dust will fix everything, or pass a law on privacy and that'll protect us all from everything that we need. Use encryption, just a little encryption, that fixes it. It's true, a little encryption does a lot of good. It's not the whole picture. It's true, some security solutions can be retrofitted. Some are designed to be retrofitted, but not all. So keep in mind the lessons that I've mentioned here, and at the same time keep in mind the references that I've pointed to. Now I'll put up the slides of references. There, as I say, are 2 slides. I'll leave those up for a minute, and at the same time I will invite questions from anybody in the audience who happens to have a question on my talk. We have about 4 minutes for questions.
Have any questions?
Yes.
Do you believe that there has been a lack in academia towards studying things like that? Because, I mean, I see people on continuous basis, either in Purdue or in any other organization, they focus on techniques for coding, they focus on networking, they focus on the technology itself, but they don't focus on the people and the behavior of people and the behavior of organizations. So do you think there's a big lack of that in academia, and would that help illustrate these problems in a scientific manner?
That's an excellent question. I thank you for asking it. It's a very thoughtful question. I don't think that's a failing of academia. Let me phrase it in a positive sense. I told you I've been very impressed by coming here at Purdue, and one of the things that impresses me is the CERIAS Institute, which has been able to bring together people from different disciplines. Not everybody in there is a networking engineer. Not everybody in there writes code for a living. Okay? And what they're doing is bringing in different philosophies, different viewpoints, different approaches to do exactly what you say. To look at the policy issues, to look at the ethical use issues, to look at the ease of use issues, to look at profiling issues. Okay? And your question is very well put. There's a tremendous emphasis in all of computing education on the fun stuff. And to a lot of students, the fun stuff is writing code, operating systems, networks, compilers, databases, that's the fun stuff. And some of these other areas, such as the policy issues, such as the ethical issues, those are less attractive to students, so departments may not offer them as courses. They may not work them into courses in appropriate places. So I think your question is a perfectly valid question. I don't see it as much as a failing of academia as just this is the direction computer science education has taken. And organizations like CERIAS are doing a great job of pulling together other professionals into the mix. Good question. Yes?
Yeah, can you comment a little bit on your perspective of that whole quantification of risk management was on an earlier slide. So my background is in data. And so you could have a loss of that data, which can be translated into a dollar cost, either impact to business or cost to reproduce the data.
Yep. Again,
and that failure can happen anywhere from a data integrity problem all the way to, the far end would be like a nuclear exchange. And so you're managing that risk, right?
Yep.
And
I'm going to
what
have
is
to
the
answer
impact
the
of
question very, very quickly because we've got 1 minute and 15 seconds left. The question is, comment on risk. The answer that I have to give you is risk is very, very hard to measure. What we'd love to have is nice quantitative data. Insurance companies have great quantitative data on life expectancy and things that occur frequently. But computer problems occur infrequently enough that it's difficult to bring together a big enough base of data to determine risk values accurately. Add to that the fact that many computer security incidents aren't reported, so getting this collection of data is really difficult. I agree, risk analysis, risk measurement needs to occur. It's a very difficult thing to do. the best approach